Hi, welcome to this video on covalent bonding. This follows on from the ionic bonding we did in that last video. So, covalent bonding happens between non-metals. So these are on the right hand side of our periodic table. So here's a quick periodic table here, and the quickest way to do this is to draw a line straight down there like this, and covalent bonding occurs between everything in this sort of section. So from carbon down to iodine, a bit of an angle, and up to fluorine. Now, helium, neon, argon, krypton, xenon, on extreme circumstances, we can get them to covalently bond, but they're full out of shells, so they're pretty stable as it is. There's also one other element that will covalently bond, and that's hydrogen. And hydrogen's a bit of a weirdo, stood out all by itself. It's there purely, really, because we'd like to put it in group 1. Just here on a lot of periodic tables you'll see it here, but it doesn't act like a metal, so it won't metallically bond. So it does covalently bond, so we'll classify it as a non-metal. So first thing we're going to look at are single covalent bonds. I'm going to take fluorine. Now, fluorine, just draw this out of shell, is in group 7. So I'm just drawing this out of shell. Some of you will be going, should have 9 electrons. There is an inner shell. I've just been lazy now and only drawing the outer shells. So that fluorine's got 7 electrons, so it's unstable. It needs 1 more electron to get a full outer shell. We saw in ionic bonding, it could get given that by a metal. If there's no metals around there, it will covalently bond with another non-metal. So for instance, it can covalently bond with itself. So we took another fluorine. This time I can do a dot cross diagram, so I'm doing its electrons in dots. We see that they both have 7 electrons. I just need 1 more to get a full outer shell. So in order for them both to do that, they overlap. So you get a nice little overlap of their electron shells. Their outer shell overlaps, and the fluorine on my left here donates 1 electron into that overlap. And my fluorine on my right also donates 1 electron into that overlap. And that leaves this fluorine with 6 remaining electrons in its outer shell, and this fluorine with 6 electrons in its outer shell. So this fluorine on my right, just put that in there. If I'm not drawing the inner shells, just to identify what the atom is, I write in the element. It's got 1, 2, 3, 4, 5, 6, 7 electrons in its outer shell that it had originally, plus now this other shared one it's got there. So it's up to 8, so it's now stable. On the left hand side, we've got 1, 2, 3, 4, 5, 6, and it's 7 original electrons, and then also that 8th one that's shared. So that is now full and stable as well. So this is fluorine, and we sometimes draw a covalent bond as a single dash. So it's F bonded to F, or F2. And this is fluorine gas. Fluorine could instead, though, bond covalently with another non-metal. The most common one that it will bond with is just a hydrogen. So we saw hydrogen was a non-metal and it did covalently bond. It's only got that small first shell, which can only hold 2 electrons. So it only needs 1 more in order to get a full outer shell, just like fluorine needs only 1 more. So again, we get an overlap. Hydrogen's going to donate 1 electron in, and fluorine's going to donate 1 electron in. There are 6 remaining then around fluorine, because it had 7 originally. And hydrogen has only put its 1 electron that it has into the covalent bond. So now the hydrogen has got 2 electrons in its outer shell, which that first outer shell is full with 2, so it's nice and stable. And the fluorine's got 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. So that's now full and stable as well. So that is HF, or hydrofluoric acid. HF. And they're single covalent bonds. So a single covalent bond is where each donates 1 electron into the covalent bond. A double covalent bond. We'll look look at now. So, double covalent. The example I'm going to look at is oxygen. So oxygen has 6 electrons in its outer shell. So it's unstable, it needs another 2 in order to get a full outer shell. So if you get another oxygen, got there, it doesn't matter where you put the dots or X's really, where you draw the Bohr's model diagrams. We've got our 2 oxygens, and if they just try to single bond with each other, that'd get them up to 7, so still be unstable. So instead, they double bond. And what they do is they give 2 electrons into the covalent bond now instead of just the 1 each. So this oxygen is going to put 2 in, and this oxygen is going to put 2 in. And we draw it x dot, oh, cross dot, to show that there are 2 bonds there as well. So drawing it like that would be incorrect and may lose you marks. So this oxygen's put 2 in, so it's got then, if you imagine those 2 have gone in, it's got 4 left. Let's put those up there. And this oxygen's put 2 in, so it's got 4 left as well. So there's our oxygen, and this is a double bond, and this is O2. It's sometimes drawn shorthand as O with what looks like an equal sign, 2 dashes, to represent a double bond with O. And that's our double covalent bond. Now it is possible to get a triple bond. Bring that down just slightly. So a triple bond, you saw a group 7 single bonded. And oxygen, oxygen doesn't just form double bonds. Oxygen can form single bonds as well. Triple bond, we can have our nitrogen, which has got 5 electrons in its outer shell. And that can come up to another nitrogen with 5 electrons in its outer shell. So they each need 3 more to get up to a full outer shell. So this time that each nitrogen atom is going to put 3 electrons in. So we've got 3 crosses and 3 dots. So that's that there. So if it's put 3 electrons in, it's only got 2 left. We've got 2 there. And this has put 3 in, so it's only got 2 left. So they can go there. And that gives me this nitrogen then with 1, 2, 3, 4, 5, 6, 7, 8. And this one with 1, 2, 3, 4, 5, 6, 7, 8. So they're both now stable. This is nitrogen, well, about 79–80% of the atmosphere that you breathe in. And it's N triple bonded to N. So just to go over that, nitrogen won't only ever form triple bonds, it can form double and single. For instance, if nitrogen wanted to bond with hydrogen, it could form a single bond with hydrogen. And that form N and H. So we see the nitrogen then is up to 6 in its outer shell. The hydrogen's now stable. So because the hydrogen's up to 6, it's unstable. It can carry on reacting with hydrogens. You can get another 2 around there. Now the nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. Each hydrogen has 2 in its outer shell. So both are stable. And that's NH3 or ammonia. So that's a quick look at covalent bonding. There'll be, again, some questions and answers below that you can have a look at and give a go yourself. Good luck.